NENOMATICA, where mathematics meets YouTube excellence. Example: construct a quadratic equation with real coefficients given that one root equals 2 minus the square root of 3. We will follow the steps shown on screen exactly, line by line. Step 1. Set the root equal to x. X equals 2 minus square root of 3. Step 2. Isolate the radical by subtracting 2 from both sides. Therefore, x minus 2 equals negative square root of 3. Step 3. Square both sides to remove the square root. Left parenthesis x minus 2, right parenthesis squared equals negative square root of 3 squared. Step 4. Expand the binomial on the left and simplify the right side. X squared minus 4x plus 4 equals 3. Step 5. Move all terms to the left to form a standard quadratic equation equal to 0. X squared minus 4x plus 1 equals 0. Example: construct a quadratic equation with rational coefficients whose one root is 3 minus square root 5. We will follow the exact 5-step algorithm shown on screen. Step 1. Start by writing the root as the variable x equals 3 minus square root 5. Step 2. Move the 3 to the left so the radical is isolated x minus 3 equals negative square root 5. Step 3. Square both sides to remove the square root. Step 4. Expand the left side using the pattern a minus b squared equals a squared minus 2ab plus b squared, and simplify the right side x squared minus 6x plus 9 equals 5. Step 5. Bring 5 to the left to set the equation equal to 0x squared minus 6x plus 4 equals 0. This is the required quadratic with rational coefficients. For intuition, notice that if 3 minus square root 5 is a root of a quadratic with rational coefficients, the other root is typically the conjugate 3 plus square root 5. Here is a number line with both points symmetric around 3. In this lesson, we'll turn a nested radical into a simple quadratic with rational coefficients. Our given root is x equals the square root of 7 minus the square root of 48. Step 1. Define the variable and simplify the inner radical. The square root of 48 equals 4 times the square root of 3. Step 2. Rewrite 7 as 4 plus 3 to make a perfect square pattern appear. Notice that 4 plus 3 minus 4 root 3 is the expansion of left parenthesis 2 minus root 3 right parenthesis squared. Step 4. Decide the sign. Since 2 is greater than root 3, the expression 2 minus root 3 is positive. Therefore, the absolute value equals 2 minus root 3. Step 5. Create a quadratic with rational coefficients. Start by isolating the radical, then square both sides. Quick check. The quadratic factors over radicals to roots 2 plus root 3 and 2 minus root 3. Our original root matches 2 minus root 3, so the equation is correct. Final answer: a quadratic with rational coefficients that has the given nested radical as a root is x squared minus 4x plus 1 equals 0. Let's write the target number and the goal on screen. Step 1. Square both sides to remove the outer square root. That gives x squared equals square root of 3 plus square root of 2. To keep work tidy, set t equal to x squared. Step 2. Work with t directly. Square t to combine the simple radicals. We get t squared equals 5 plus 2 times the square root of 6. Move the 5 to the left and square again to remove the remaining radical. This produces open t squared minus 5 close squared equals 24. Step 3. Expand the left side and simplify. We obtain t to the fourth minus 10t squared plus 25 equals 24. Therefore, t to the fourth minus 10t squared plus 1 equals 0. This is a quadratic with rational coefficients satisfied by t. Step 4. Recall that t equals x squared. Substitute back to convert the equation into x. Replace t by x squared to get x to the 8th minus 10x to the 4th plus 1 equals 0. And here is our goal: a quadratic with rational coefficients that has this x as a root. Step 1. Rationalize the denominator by multiplying top and bottom by the conjugate, which is square root of 3 minus square root of 5. Now use the difference of squares in the denominator. The denominator becomes 3 minus 5. The numerator becomes the square of square root of 3 minus square root of 5. Expand the numerator using the square of a binomial. A minus b squared equals a squared minus 2ab plus b squared. Combine 3 and 5 to get 8, then divide each term by -2. Great! Now isolate the radical by adding 4 to both sides. Square both sides to eliminate the square root. Expand the left side and bring all terms to one side by adding 4 to both sides. Square both sides to eliminate the square root. Expand the left side and bring all terms to one side to form a quadratic. Expand the left side and bring all terms to one side to form a quadratic. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.